this video, I'm going to show you how to control a block signal with a three-way switch. This is an on, switch. That's all you need. No external circuitry, no magic. All you need is the correct switch. Okay, before we get into how it's wired, let's take a second to look at these two switches here. Got a red one on the left and a blue one on the right. They almost look like they're the same switch. We got position 1, position 2, and position 3 on each switch. We got 6 terminals on the back, so that means they're the same switch, right? This would be similar to the same switch that you would use on your DC layout, where you wanted to switch your polarity and have an off position in the center. You would use a switch exactly like this. It's called a double pole double throw switch. Basically that means there's 2 sets of contacts in here. Each row here has its own set of contacts, and when you flip the switch one direction, it'll connect these 2 terminals together, and separately these 2 terminals together. Then you flip the switch to the middle, and then there's no connection between any of the terminals. Then you flip the switch all the way down. Then you move the contacts to between these 2 terminals here and these 2 terminals here. Now the red switch is not like that. The red switch is called a double pole triple throw, and it's built a little bit different. Okay, this is internally how this switch is connected. When the switch is in the up position, you have terminals 5 and 6 connected, and you have terminals 2 and 3 connected. For example, that would be terminal 5, terminal 6, terminal 2, terminal 3. Now in the center position, terminals 2 and 3 remain connected together, but now we have over here on this side terminals 5 and terminals 4 connected. It would be terminal 5, terminal 4, terminal 3, terminal 2. Then in the down position, you have terminals 5 and 4 connected still, but now you have terminals 2 and terminals 1 connected. That'll be 5 and 4, and then 2 and 1. And finally, this is how you can wire it to a 3-aspect signal to control it. For LEDs arranged in a common anode configuration, you can connect your green LED to terminal 6, your yellow LED to terminal 4, and your red LED to terminal 1. Then terminal 2 gets connected to ground through a LED dropper resistor. And the other thing you have to do, you have to run a jumper between terminals 3 and terminals 5. So when the switch is in the up position, we have terminals 5 and 6 and 2 and 3 connected together. So here I've drawn them in. So you have your power coming in, goes through the green LED into terminal 6, goes through the switch contact, comes out terminal 5, goes through the jumper to terminal 3, back in the switch through the contact to terminal 2, then from terminal 2 through your LED dropper resistor to ground. And that will illuminate the green LED. Then in the center position, we have terminals 4 and 5 connected together, and remember 2 and 3 are still connected. But now we have our power come in through the yellow LED, into 4, through the switch to 5, out through the jumper to 3, back into the switch over to 2, then out 2 to ground through your resistor. And finally, in the down position, terminal 5 and 4 are still connected together, but we now have terminals 1 and 3 connected together. So in essence, the yellow LED is not connected to anything. So your power comes in through the red LED to terminal 1, into the switch through the contact to terminal 2, and then out of terminal 2 through your dropper resistor to ground. And that will allow you to control 3 LEDs with this 3-position switch. And here's a simplified wiring diagram. In this diagram, I've included the dropper resistor in the common supply wire, the anode, because that's how most of the eBay signals are. So it's the same idea. You connect your terminal 6 goes to your green LED, terminal 4 goes to your yellow LED, terminal 1 goes to the red LED, then you have to install a jumper from 5 to 3, and then terminal 2 is your negative, your ground. Your power will come in through your dropper resistor, and it will supply the anode of every LED with positive power. The switch will connect 1 LED at a time to ground. Okay, here's our little test setup. See, we have our green LED connected to 6, our jumper from 5 to 3, our yellow LED to 4, ground to 2, and 1 is connected to the red LED. Okay, here's one more test setup. This time with a LED signal from that very truthful Chinese vendor on eBay. So we have it all connected up. We have the common resistor on the common anode of all the signals going to the power, to my power supply, the positive power. Black wire here from the switch is connected to ground, and then all the individual colors are connected to light colors on the switch. And we'll just flip the switch. It's as easy as that. So now you're probably wondering, if I wanted to build one of those for my layout, where do I get that magical switch? Well, I have not been able to find them on Amazon, but I have found them from 2 major electronic component distributors. These switches are readily available from both Digi-Key and Mouser, and I'm sure they're readily available from other electronic component distributors as well. And I'm going to give you the manufacturer's part number of the switch, and all you have to do is type it into the search bar on any electronics components distributor's website, and if they carry that switch will come up. It's about $5 or $6. But $5 or $6 is a lot cheaper than spending a lot of money on a block signal controller if all you want to do is just change the lights every now and then. So there you have it. Easy manual block signal control with a 3-position switch. I'd like to thank you for taking the time to watch my video. If you found it useful or interesting, please take a moment to like the video, and please consider subscribing to my channel for more content. Thank you.